Yo, cool. Welcome to the internet. This is what it looks like. All right, it's right here. Ooh. Oh yeah, you like that little zoom action?
No.
Oh, it's gonna be rough. I use it a lot. All right. So I want to highlight some things. All right. So we're gonna follow Swabat for a little bit, and then we're gonna kind of taper off. But does anyone remember what this is? All right. Very good. So explain in general how the internet works, right? Like you're all web developers now. It'd be crazy if like your girlfriend, boyfriend, or your mom comes up to you like, oh my God, you're building the internet. Like, cool, how does it work? And you're just like, I don't know. That's kind of like not the right answer, right? Cool, we'll define what the World Wide Web is, describe the client-server model, and as I've described to you on Friday, it's probably a blur, the request-response lifecycle. We'll utilize a browser to make a request and we'll see a response and I'll describe what's happening there, and then we'll practice making a web server with Rack. Any questions? Yeah, I didn't think so, right? That's kind of like pretty straightforward. All right, good deal. We're not going to talk about the history of the internet, so we're going to go right into this right here. What is the internet? Does anyone know?
Bunch of cables.
That's right. It's just a bunch of cables. Yeah, it's cables and servers, but really it's just like a bunch of wires, right? Look at this. The internet is a network of computers all connected by cables. Cool? So, nice. So basically, the way to describe it is, who here is like ever moved? By show of hands. Moved? Yes?
Yeah.
All right, what's the first thing you do when you move? Okay, cool. I did not expect that answer. It's more along the lines of like you're in your apartment, right? You check to see if the gas is on, maybe you turn the water on, and then what?
Connect to Wi-Fi.
That's right. You try to connect to Wi-Fi. So the first thing you do is you call your cable company, and you're like, yo, I need some of that high-speed internet. You know what I'm saying? It's 2019. No more dial-up. Just by a show of hands, I'm not asking your age, but like, who remembers dial-up? Okay, good. All right, I'm in the right room. All right, so the idea here is that you called this cable company, and they told you an extremely convenient time that they're going to be there, right? Sometime in the next 3 or 4 days between the hours of 9 to 6, right? And then what did they do when they actually came?
Not much.
Yeah, not much, sure. Does anyone actually know? Yeah, like if you didn't already have internet in this apartment, let's say you had a brand new house, they will literally drill holes through your walls and run cable into your house. And all these cables that you see on the streets, if you actually like look up for once because you're like not jaded New Yorkers, and then you actually see all these wires and they actually run into every single building. And that wire connects to a bunch of other wires that are connected to a bunch of other computers. And that's what the internet is. The cloud, it's not literally like a cloud, it's just that you're connecting to what is known as like a bunch of other servers somewhere else that's not inside like your home. Cool?
Cool.
Noise. All right. Any questions on like how the internet like kind of works? Everything is just kind of connected. So there's a individual by the name of Alexander Graham Bell. Sound familiar? Yeah? All right. He literally just ran a wire from like one house to the other and just called him. Just picked up the phone, was like, yo, dog, what up? It's me at number 1. We're calling you, you're like number 4. Like, obviously they didn't have like 7 digits back in the day. So, yeah. That's what it is, except this time you're sending information, not just voice. And everything has to be connected by wires. Is anyone like confused? Like, how does Wi-Fi work then?
Radio waves?
Yeah, so basically what you have is you have this wire that's run and it connects into a router. That router will literally beam over radio waves the data. And then you have a phone or you have a laptop that can receive these waves and then translate the data that's through the radio waves back into the original data. And then that's basically what Wi-Fi is in like a very high level. Cool? I'm sorry I'm boring you. All right, cool. So, quick history, right? Boom. We have this right here. This is right now is kind of generally what the internet looks like today. There's just all these wires, and they're all They cross continents. They just run under seas, and they just connect everywhere. The first sort of wire here was, all right, I'm going to Google a lot in class just so you can see it for a couple reasons. One, I don't know everything. And two, I want you to see how I Google. And then that way it can kind of get you familiar with like getting better at Googling. Cool? All right, let's check this out. So that's not a good picture. Where is... It's not useful at all. Maybe this one? Boom! All right, cool. So this is like basically like the original like net, ARPANET. I forget what it stands for, but it was between all the universities across the country. Naturally, you would think higher education, where they wanted to share information between schools, would be like the start of this. So it started in UCLA and Stanford, so both like over here in this area. Boop, boop. All right, cool. And basically, what they wanted to do is they wanted to connect these computers first, and they hooked them up to a wire. They literally ran one long wire from school to school, and they connected two computers. And they wanted to see whether or not they can transmit data over. So they decided to send over the word login. All right, this is pretty standard stuff. Who here, their Mod 1 presentation or any presentation you ever did was just went off without a hitch? It was like perfect. All your code ran. The video was good. The sound was good. It was well executed. Wow, lucky you. You as well? Wow, life is easy. All right, so what happened is the first letter came through, L. I was like, all right, money. They're all celebrating, they're happy. O came through, and then right as it got to G, it crashed. It was like, nope, just kidding, psych. And then the server died. And so, I don't know, I just make this terrible joke that's like original sin. So like all your presentations, all your demos, all your code always break the first time. But that's cool. All right, good deal. This class is very interesting. So that's basically what happened. And wow, you guys like GIFs? All right, good. All right, so these are what the wires look like, right? There's just insulation layer, some copper tubing, some steel wires, and then another layer of steel wires protected by this water-resistant petroleum jelly, and then finally you have these optical fibers. So you're literally transmitting data over these wires at the speed of light, which is why internet comes through so quickly. So if you are physically located closer to a server, it will come through just that much faster. And so in order to increase the speed, they have to increase the number of servers in different locations, and so that you're just that much closer. You ever run like speed test or anything? Yeah. All right, and then like zoom in and locate what server you're kind of close to, and they test it that way. That's why. Cool?
Yes. Yeah.
All right, eat. All right, cool. So there's this guy by the name of Vincent Cerf. He's actually still alive. Yeah, he like invented the internet, and he's actually trying to create this internet 2.0, if you're interested. It's more about like privacy and who controls the data. Because right now, who controls the data in terms of like the user or the developer or company? Yeah, and right now they're trying to create like a new internet where you as the user control all your own data. I don't know how it's going to work, but be interested to hear about it. Cool. He invented something called TCP. Does anyone know what that stands for?
Transfer control.
Yes. All right. CS guy?
Yes.
Noise. All right. Cool. I will lean on you heavily. So the transfer control.
We learned this in college.
Huh?
We don't learn this in college.
Oh, you just studied it on your own? Smart. So the TCP, right? It's just the transfer control protocol, right? All a protocol is just a step-by-step on how to do something. Transfer control is just, I'm going to write step-by-step how I'm going to transfer and control the data that gets sent over the internet. Usually with TCP, there's two other letters that usually go with it. Does anyone know what that is? Any of those two extra letters that normally accompany TCP? Any idea?
No idea.
Oh God, this class is rough. You guys are a bunch of hecklers. Yeah, it's IP, right? And what does IP stand for? Cool. For those that did not know, it's okay, right? Like, don't be like, oh man, I was the only one that didn't know that. Like, it's fine. This is like where the lesson comes in, right? So you have a transfer control protocol and an internet protocol. Again, the protocol is more like how to. And so what this is in conjunction is how am I going to send information over? And then the IP you can think of as literally like an address. So the metaphor I'm going to give you is, who here remembers like somebody else's phone number? Yeah? Okay. Wow, what a waste of space. Right? No, but seriously, I like only remember my mom's number, which is kind of sad. But like back in the day, in like elementary school, I had like 10 numbers in my head, like my best friend, my house number. Actually, it was everyone's houses. It was everyone's house number. I didn't have like cell phones. Dark ages. It was rough. But what IP address can essentially equate to is what your phone number is that points to your particular device. So whether it be a laptop or a phone, your IP address points to yours. So we don't actually use this anymore as it currently looks face value. So for example, when you're trying to call your friend, right? What do you do on your phone? Do you dial the number, or do you just look in your phone book and you're like, yo, I'm gonna call Bay, I'm gonna call Boo, and you look up B-O-O or B-E-A-U, right? You know what I'm saying? And then you just click it, and then all of a sudden, homeboy or homegirl's on the line, right? You didn't dial the numbers anymore. So it's true, right? If I wanted to go to a website, right? I don't know, like Google, I would just go to google.com. I don't actually go to, I don't actually go to Google's IP address anymore. Hey, shut up, lecture. I don't actually go to Google's IP address anymore, right? I literally just go to the name. It's like a phone book. And so there's something called the DNS. Is anyone familiar with this?
Domain name server.
Oh, my God. All right. So if you don't remember, you just, what is this? DNS. Domain name system. I knew it was like a little off, but it was close, right? Yeah, plus plus. Cool. And what it is literally the phone book of the internet. So if I go to google.com, this DNS, it will tell me what the IP address is of this place. And then I will actually go dial that IP address's number, hit that server, get the data, and then it will come back. Right? And you can prove this. You're all on Macs. You have something called network utility. Cool. You can run traceroute on anything. Like if I want to go to bookface.com, it'll trace action, and you can stop it immediately. And it'll tell you, oh, here's the IP address. Cool. Who here wants to sign into Twitter, or Instagram, or Facebook and be like, great, I'm just going to go check out 31137136 and log right in? Nobody. Ridiculous. But if I were to actually go to this port, this IP address, it defaults to port 80, and it'll work either way. But look, check it out. I wish the internet was faster. Anytime you're ready. And there it is. Boom. Bookface. Oh, snap, I'm logged in. Great. All right. Oh, that was embarrassing. I haven't been on Facebook in a long time. Either way, so that's basically the DNS, the IP address, and that lookup. Are there any questions so far as to how this DNS kind of like looks up? You literally put in like a name, just like you would in a phone book, and then it will return you the IP address. The IP address is actually the location of where the server is, and then you get that data from that server.
So when the IP address is established, is there a possibility that it will change, in which we need to manually change how we grab that information?
There are much higher level technicians that will adjust that, and there's a lot of scripts already written in the way your computer will look up DNS, that if it's not in your local phone book, so like every computer has a local DNS, right? Like popular websites, I'm sure like Macy's.com, Google, Bing, Yahoo, they're all stored locally. If I have to go to a website that I've never been to before, it will look in the local, see if there's a name there, and if it points to an IP address. If not, it will reach out to other DNS servers to kind of look it up, and then if they don't have it, it'll just keep going until it finds it, and then it comes all the way back, and then finally gives it to me. So the first time you go to a website, you'll notice that it takes a little bit longer to go to. And then after that, it's cached, and it's faster. Cool? When I say cached, I don't mean like cash money. I mean like cash. Cool? Just so you know. Smart. Question? Oh. You don't have to be scared about it, you know, like you can feel free to ask questions. Awesome. Awesome. Cool. All right. So let's bring it all together, right? We have the client. So prior to this program, you've just been what is known as like a consumer. And so you are just the client, and the client is the person that makes all these requests. You make these requests through the browser, and so the client is always going to be referred to as the user, as through a browser. So Opera, do you remember like Dolphin, like BlackBerry browser? No? Okay, all right, it's fine. Those technologies are a little different. You have Chrome, you have Firefox, Netscape Navigator. All right, 2 people, cool, good deal. All right, these are the same people that got like 800 free hours of internet on a CD from AOL. Man, what good times. Net zero? All right, that's okay. I lost you. Anyways, cool. So you're now going to serve as both the client and as the server. As we build up these servers, you'll start to see kind of the logic that happens behind there as we build out the framework of Sinatra. And then you will make the request on the client to the local server, and then the server will actually take that, process it, and then send a response back. And so you'll enter that request response cycle. All right, boom, boom, boom. Cool. Does anyone need a break, or y'all Gucci? Man, you guys are tough. Tougher than woodpecker lips over here. Nice. I have a lot of weird isms and sayings. You'll get used to it. You're tougher than woodpecker lips. Yeah. No, it's weird. Thank you. Yes, I heard that. Yeah. Be good. All right, cool. All right, in that case, we'll start with like a terrible joke. So now that you know what the internet is made of, all right, what is the greatest threat to the internet? Does anyone know? All right, it's sharks, right? So I didn't know for a long time, then I finally found out. Look, this is just an underwater camera. Apparently the heat that comes out of these cables, the sharks will think it's food, and they'll just come by and go, yo, I'm hungry, son. And just chomp it. I know, dirty. That's, oh damn! When's the last time you saw that buffer happen? Anyways, yeah, it just attacks it. And then it's like, nah, nope, just kidding. And then it'll just leave. So, yeah, this is the greatest threat to the internet. I don't know, I put this stupid GIF in here. You guys watch like, man, who played Batman? A long time ago, look at this. Adam West! Saving the internet over here.
Shark repellent.
Oh yeah. He has like a shark repellent spray that he uses. Man. Imagination. Cool. Yeah, he's not doing it right. Greatest detective, my butt. All right, anyways. Great. So now that we've learned a little bit more about the internet, kind of how it works and what that lookup is, I'm actually just going to give you a quick example before we dive into documentation. We learn how to look up information about the internet, and then we'll set up our own local server. Cool? Nice. All right. So I may or may not have these high-speed drawings. Cool. We'll start with this one. All right. This is obviously a very advanced animation. All right. So this is you, the client, right? This is your home, your house. You're on the internet, and you have to use something to connect to. This black line is just the internet, right? It is like all the wires. That's what it symbolizes. And you're right here, the client. Cool. If you wanted to connect to the internet, you would need somebody to provide you access to the internet. This is known as an internet service provider. That language just makes a lot of sense. Does anyone know an example of an internet service provider? Those thieves. Okay, Time Warner Cable, very good. I'm old. I'm old. It's like Spectrum now. It's like Verizon, Spectrum, right? You have like Cox. What else do you have? I don't know.
Soon will be Tesla and Google.
Yeah, Tesla, Google. So the idea here is that like you cannot really connect to this directly. And so you'll need somebody, you'll have to pay them an absorbent amount of money, which will throttle you. My opinions are coming out, I'm sorry. Uh, and you'll connect to the internet here. So if I wanted to, right, in this scenario with this diagram, send an email to old girl, Aunt Ruth here. This is the process that happens, right? I'm in my house, I'm chilling in my PJs, and I miss my Aunt Ruth. It's her birthday, and I want to send her a little message because I'm a good nephew. All right, so I log in, right? I go on my computer, I turn it on, and it connects to the internet through my internet service provider. I literally write up an email on Gmail, because I'm in the future, and I hit send. I hit send. So I'm sending data through the internet. If you remember my very quick fireside chat on Friday, that is known as a post request. I'm going to send data to the server. I'm not actually requesting information. I'm sending data over to the server. Cool? So I send this post request, this email, and it goes through my ISP, and then it connects directly to the internet. The Gmail server, through the DNS lookup, will tell me somewhere that this is where the Gmail server is. Cool? This request will hit the server. The server will then process that request. So the data that I sent through the email, those are the parameters, right? I have some sort of head, right? Some email, like name, my email address. I have a subject and I have a body. And then Gmail servers will do something with it. They'll be like, cool, great, got this data. Where do you want to send it? I have a to email address, right? Aunt Ruth. And they'll be like, cool, got it. That's on the AOL servers because Aunt Ruth signed up a long time ago and she doesn't want to change. It's like ruthie@aol.com. Cool. It will go back through this little like internet pipe, come over on the AOL server through those wires. You've seen these wires before? These things over here?
Yeah.
Take me home, country roads. All right, so it goes through and then all of a sudden it hits Aunt Ruth's. When she logs in, she will actually connect back to the AOL server and make a request for information. She will make a GET request to see, hey, is there any data in my inbox? And then she will see the email. And that's generally the process of what's actually happening over the internet. Are there any questions? It's like pretty straightforward, right? Smart. All right, cool. Let's take a look at this one. All right. So we, however, don't connect directly. If you want more than one connection, you don't like hardline your computer anymore right into the modem. We connect it to what? The router. So let's say you and your boss are both just chilling at work, right? This is my IP address. I'm 192.168.110, and my boss is 168.1.1. If we both make a request, how does the router know, how does the request know where to send the response? So for example, if I wanted to go to bookface.com because I'm a productive employee, and my boss, being a good boss, wants to go to marketresearch.com. All right, if we both make a request, how does it know which request will go where? And then on the response, how does it know to come back to go to which proper computer?
IP addresses.
IP addresses are important. Inside the request, there's a lot of data. And part of it is going to be who the requester is, and they store that IP address in there. So if I'm just going to like bookface.com, I'm going to hit the router and go, hey, where's bookface.com? It will tell me it's at 6963.178.11. Cool. It'll hit the ISP. It's like, hey, I need to go to 6963.178.11 with this GET request for information. It'll hit some more routers over there, and it'll tell me that, hey, it's this way. It's this way. I'll get the information. It comes back, and when it hits this router, it knows which computer to send that data back to, and it'll come back to me. Cool? Are there any kind of questions as to like routing, DNS, and just what it sort of looks like? This happens at the speed of light, so you can't really like trace your request. You know what I'm saying? like visually.
Cool.
All right, awesome. Cool. All right, so let's actually take a look at some documentation for the internet. Does anyone know where to look?
Internet.com.
Internet.com. I feel like this is a sketchy website that somebody like a long time ago was like, this is going to be big. It's going to be huge. All right. God. See this right here on the bottom? You can't really see it too much. Resolving host. It's actually doing the DNS look. I've never been to internet.com. I don't think anyone. All right, I'm just going to tell you. Spoiler alert. It's the MDN. All right, the Mozilla Developer Network. Yo, why is the internet so fast? Oh, whoa. Did you see that? Dang, that website was legit. All right, please check it out on your own time and let me know what you find. All right, so the Mozilla Developer Network. These are the folks that make Firefox, and they actually hold all the documentation. Not all of it, but they do the documentation for sort of the internet. Here you can see the technologies, HTTP. And what does that stand for? Does anyone know? Hypertext Transfer Protocol, right? And all it really is again, the protocol is how something is sort of done. Hypertext transfer. What is HTML? Yeah, the hypertext markup language. So HTTP is literally the breakdown of how to send and receive hypertext. And that looks like this. If you hit, I'll just show you the slow way. If you right click and hit inspect, you'll get this little thing over here, this bad boy. Look at all this hypertext. Boom. This head tag, some body action, some JavaScript. If you're not good with HTML, you will get significantly better in Mod 2, and then you will get even better in Mod 3. The basics that you should know and understand is at the minimum, like what a H1 tag is, a div tag, like a p tag, a linked, so like an anchor tag. You can find all of this on W3 Schools, right? If you ever wanted to know what something is, you just look them up. And there's like pretty good definitions, and they'll even give you examples of how to use them and what they will produce once that markup language has been interpreted by a browser and then displayed and rendered on the screen. So here's what's happening. For those that need the quick refresher, the server just sends back HTML, just text, right? This is what all your websites basically look like, this right here. Right? Is this a good user experience? Do you feel like you can navigate a website just looking at this markup language?
Oh, yeah.
Yeah? Powerful. Yeah? All right, this is like a terrible user experience. So what actually happens is the browser will read this HTML, include some CSS styling, and then ultimately this is what you will see. This is a much better user experience. And that's basically what's happening. Cool? So what we want to talk about is those requests, specifically HTTP verbs. So here we'll have something called request methods. There's several methods, but we'll only be focusing on 4 kind of 5. All right? We talked about this GET request. What is the GET request? What is this HTTP verb of GET?
Ask.
Okay, fair. All right. You're just requesting for information. Remember, you're not actually sending any data over to the server. So if I wanted to go to google.com, all right, and I just go into the browser, I'm like, great, google.com, and I hit enter, that is going to be a GET request to google.com. Is that fair? If I hit enter, great. In this search bar, all right, I can be like, cool, I want some data. If I were to actually hit Google search, am I sending any data to the server?
No.
Try again.
Yes.
Yes, right? Very good. That was a 50-50 shot. Right? I'm sending this string, the string of I want some data. And when I hit Google search, I'm going to send a post request to the Google server. And that way, Google knows that I've just made a post request to google.com. Google handles the GET request and the POST request differently. So if there's a GET to /Google, then it's going to give me the standard Google HTML. If there's a POST request, to /Google, then Google will be like, okay, this is a different request. There's a different route happening here. And then I'm going to take the data, the parameters that were sent through, I'm going to do something. I'm going to run my smart Google algorithm, and then I'm going to send back a response based on the data that was sent over. Does that make sense? That being said, this is not a trick question. This browser search, what kind of request can this make? Do you think this can make any sort of post request?
Yes. Yeah, I think Chrome can.
How?
Google. You had all the other syntax.
Yeah, you're really just limited to GET requests because you can only request for information in the browser. There are tools that you'll learn about that can like simulate post, put, patch, and delete requests, which we'll talk about right now. But you can only make GET requests. All right, so cool. We talked about GET, right? It's just an HTTP verb. And it's just asking for information. Post, you're just going to be sending some data. And this typically is used for some sort of creation. So if I wanted to upload a new photo to my Instagram, I'm going to make a post request. This post request is going to contain literally the image file that I'm going to send to the server. And the server is going to be like, cool, this is great. And then it's going to save it to the database and then come back with a response. The response is going to be, nice photo, here it is, and show it to me on the actual website. Are there any questions on that? Smart. Then you have something called put and patch, right? These two right here. Does anyone know the difference between put and patch?
Spelled differently.
Nice. All right. So yeah, you got like 5 letters versus 3. Efficiency. All right. Cool. So the put and patch, they're both updating functions, and they will both update your database. And so the first thing is, inside your database, you have these columns of data, right? You have a user, there's some sort of like username, maybe an email, like a password column. Have you ever updated your profile or anything? Like LinkedIn or Twitter or anything? Cool. Did you update every single thing in your profile? Imagine you want to update just your password. Do you want to retype in your username? Do you want to retype in like your first name, your last name, and re-upload a brand new image to your account for your avatar? No. That would be an update to the entire row in your database. That is known as a patch request. I'm sorry, a put request. You're going to be putting brand new data in every single column inside your database. A patch request is like, cool, I just want to change my password. You're literally taking one column inside your database, and you're just going to patch that up real quick. Little fix action. And so if you had to pick one as a default between patch and put to update on your server, which one would you set as the default? Smart, yeah, so patch, right? So very often you'll see patch. Cool. But if you see put, just kind of know the difference. You will almost never use it though. And then lastly, delete. Please tell me someone has an idea of what this does. Yeah, it just sends some sort of delete request to delete something in your database. And that's really about it.
Is it something in the database or is it the entire row? Or could it be like a patch or like post?
It'll be like deleting like the entire row. Smart. Cool. Are there any questions so far about the 5 HTTP verbs that we just went through? I just want to give you a heads up. There's a lot that's going to come at you this week in terms of what you have to actually know. So HTTP verbs are very important, and they will prepend any routes that you build in Sinatra. Who's gone through some of the Sinatra labs? Cool. So you literally have to write the HTTP verb followed by the route, and that's going to determine what actually happens in that route. Does that make sense? Smart. Cool. Oh man, I think that's really about it. Yeah. So right now we're typically on HTTP 1.1. There is a 2.0, and for 1.1, you kind of, spoiler alert, the internet is like broken. It's like barely held together, and right now the browsers can only really respond to GET and POST requests. There are like really sneaky, hacky things we have to do to make it understand patch, put, and delete, and we'll kind of go over that this week. But just so you heard it from me, just GET and POST. Cool? Awesome. All right. Let's actually talk about what we have in terms of like this code, and then we'll mess around and start up a server. Look at that. Thank you, Batman. All right. So here we just have like a song class, right? What is this? What kind of variable is this?
Class variable.
Right, class variable. And all it is it just initializes with the title, and then you have this class variable, and it pushes itself in there. Nothing crazy, right? All right, this class is weird. You guys like laugh at a lot of things, and then like other times you're just, I'll figure you guys out. It'll be fine. All right, cool. Here we have just like a config RU file. All it does is it requires rack and it requires app, and it runs app.new. That's all it does. This is what app is. So we have our friend Pry, and we have song, the file. All I'm going to do is create this class because class, like class.new, right, app.new, is actually going to create an instance of this. I have a method called call. It takes in an environment. And all I'm doing is creating two variables. A request, which is a brand new rack request, and then a response. Any questions so far? Wow, okay, all right. So here we have like a little to-do. When you write code, trust me when I tell you, get into the habit of commenting all your code. This is very important because I promise you, in a week or two, if you were to take a look back at your Mod 1 project, you're gonna be like, what is this? And it's like literally a week. So as you start working on like larger code bases over the course of several months, you're gonna be like, what? I've done this, I'm guilty of it, as I'm sure every developer has. I will look at a piece of code and I'm like, who wrote this? This is trash. There's a command. Are you guys familiar with Git?
Yes.
Somewhat? Okay, there's a command called git blame. And it will tell you every single line of code, who wrote it. It will tag your GitHub handle for every line. And I was like, yo, who wrote this trash? And then like right here in this little code block, it said Evans Wang. And I was like, okay. Embarrassing. But either way, comment your code, cool? It's good for readability as well as a reference to what something does, as well as like this is common convention where something works, but there's more to add, and you'll write little comments to yourself or other developers to kind of pick up where you left off, right? So here it says create some new songs. Great, we'll do that here in a second. This right here is just a plain old if statement, and if the request, right, has a path of /songs, this right here just means match. Cool. Then all I'm going to do is I'm going to map through all the songs and create li tags with the song, specifically the title of that song. Otherwise, I'll just have this song object and it won't really come out. And then what I'm going to do is write inside the response an h1 tag, which is just like a header, an unordered list, and then let's do this. Let's actually do a little bit of this. Bloop, and put inside song list items. Cool? And so I'm creating, remember, li tags for every single song that I have. If, however, the route is to /artists, then I'm just going to have a list here. Else, which means what in terms of the path? Anything that's not songs or artists, right? Then it's apparently going to say not found with some random image. And then I'm going to say that that response is done. So I'm going to start up my local server. Cool. How do I do this again? All right. It's just called rackup. It's a command rackup. It will start a local server. This is like the PID. You'll learn more about that. This is the port 9292. So I can go to localhost port 9292, and I will see. Look at this. Not found with this high-speed individual over here. Well, and that makes sense because was my route /songs or /artists? No, so that means it must have hit this else block. I have a not found, and obviously this image right here is like some old man like just shrugging. Cool?
Yes.
Okay. Very good. So how can I see all the artists then?
/artists.
All right, I would just go to localhost, right, /artists. And there it is, artist list. Why is nothing in here? Yeah, I haven't wrote anything in here, right? What if I want to see all the songs? Okay, cool. Let me just check that out real quick. Let me make a request to /songs. Boom. Yeah? No? Yes? No? Okay. Anyone else have a song you guys like? What are you guys listening to?
You can do below in reference to Flash.
Hello?
And it's my favorite song.
You mean by the man himself? Lionel? That man goes all night long. You know what I'm saying? Fiesta? All right. Bruce Wayne?
B-O-S.
B-O-S?
Yeah.
Booze Wayne?
Yeah.
I am out of touch with reality. I have no idea who that is.
I think weird suits.
Bruce Wayne? I don't know.
D.A. Rivers.
D.A. Rivers?
D.A.
Wow. Okay. Jack? I don't know, man. I think artists nowadays have like Lil in front of them, right? Right. And then Lil Jack? Powerful. Cool. All right. Great. Anytime you make changes, so the thing about the server is it doesn't like take your changes immediately. Unfortunately, you have to hit Control C, shut the server down, and then restart the server. It's embarrassing. Later on, you'll learn something called shotgun, which as you update your code, it will update the server, and then you just hit refresh on the browser and it should be good to go. And there it is. So something I want to point out before I kind of let you go is this website static or dynamic? And what does that mean? Who thinks it's static? Who thinks it's dynamic? Okay, cool. It's dynamic, and let me explain. Boo! Yeah, very good. All right. It's dynamic because this right here is essentially pulling from what is effectively here a database, right? I have all these songs, and then no matter what I do, as I add more songs, it will create more of these LI tags. If it was static, I'd have to hard code the data every single time, meaning I'd have to do this, LI, and put, oh, this is trash, all right, LI, like song number 1, cool, and then I have to do, great, a new song came out, cool, I have to make another LI tag, and great, like, boom, top 40, da bomb, cool, and then like add a little emoji in here, like bomb, y'all like that? Y'all like that? If you hit Command, Control, Spacebar, it brings up the emojis, and they actually run. So we'll take a look. Yeah, I know. Powerful. So, dank. All right. Oh, wow, that was embarrassing. It normally comes out. That was weird. Huh. Anyways, that's the bomb. So, this is what is known as like being hard-coded. No matter what I do, even if I add another song to my database, it will only render the HTML that I've hard-coded. So if something is hard-coded and it will never change unless you actually go in and change the HTML, it is static. If you are pulling from some sort of data and then rendering based on data or a database, then it will be a dynamic website. Does that make sense? Cool. Like for example, I don't know. What's a website I built? Tier 7? Cool. Literally nothing about this website changes. Oh, it's too slow. Nothing about that website will change, right? It's just like cool, this is my site. It's like my friend's website. I just built it for him. Cool, this is my site. This is my company. Here's what we do. Here's like a contact form. Shoot me an email if you want to learn more. Nothing about that site will ever change unless he tells me, hey, can you like add this one sentence? I'm literally going to go into that website, that HTML, and add the sentence. And that's it. That's a static website versus something like, I don't know, CNN.com or New York Times or, I don't know. Do you think these articles change every day? I hope so. Cool. Do you think somebody is literally changing the HTML every single day based on the articles that are on here? No. They probably have some sort of like HTML template, and then they go, great, here are the 3 articles for the day, and it's like from a database, and it just pulls the top 3 articles. So this is more of like a dynamic website. Are there any questions on static versus dynamic? Yeah?
So, like a real-world application, in what instance would you use a static website?
A perfect example is if your friend goes, oh my God, you're a web developer? Yo, listen, I got this great idea. Except the idea is not fully fleshed out. They're like still waiting for funding. Like you have a bunch of investors. And it doesn't like display anything. So like, look, this right here, this is like my friend's website, right? Like, cool. Will this ever really change? Do I need to pull this data from a database? Like who we are by mission statement? No, right? Cool. Like there's like a cool graphic here. And then there's like a let's chat. This is just like a email form. So a static website is more just like displaying information. Yeah. Otherwise, everything else would be essentially dynamic. Like your Zangas, you know, dynamic. Okay, like 3 people. Very good. Thank you. No? All right. Are there any other questions as to like what the internet is? All right, let's go back to this README. Cool. If you have a markdown file, if you hit Control-Shift-M, it'll give you a little preview of it as it looks in the README. Cool. Does everyone feel comfortable about like generally how the internet works? It's just a bunch of wires and they're all connected. They send data to each other. Cool. What is the World Wide Web? I don't think we actually talked about that. Yeah, the World Wide Web is the interconnectivity between all of the computers. That's really what it is. Like it looks like a web of like wires. It's right here. Yeah, that's really about it. Cool. What is the client-server model and the request-response lifecycle? Let's talk about that for a second. Aunt Ruth? Yeah, I mean that's pretty much the diagram, right? But how do we create that inside the rack server? Inside the app, right? What I did was just started this new app. I started this local server. If I made a request to localhost/songs, I received this as a response, response.write, and it served me back this HTML. And then at the end, it finished that response. If, however, these were like anchor tags, right? Let's do this. Anchor tag, what is it, source? And it was like google.com. Cool. Let's take a look. Shut this. This is a terrible user experience. Cool. I go back to localhost and I refresh. Come on. Did the server not go up? What the? Oh, it didn't like that. Let's do this. Oh, I see. Single quotes. It's more, because I'm already inside double quotes here. Punk. There we go. This right here, I wrapped the whole thing. Oh, wow. Of course it doesn't work. That is bizarre. I'm surprised that rendered. What a powerful user experience over here. Ugh. Oh, that's right. It's not source. Source is for image. Ugh. That's embarrassing. That's embarrassing. Thank you. Oh, my lord. I should. There it is. Oh, thank good. It's going to try to go to localhost9292/google.com, which, as we know, is not going to work, right? And so here's what's happening under the hood in terms of this request response. First, I made a request to /songs, right? I looked at it. I was like, cool, there's a list of songs. And then on that page was a link. And I clicked that link. I made a what? Yeah. I made a new GET request to localhost 9292/Google, which like didn't work out. I think if I put this, it'll actually work. All right? Yeah. Either way, the point is, every time you navigate something, you make another request followed by another response. If you click on something, you make another request followed by another response. If you submit a form, you're making a post request followed by a response. So the internet is really just this request response cycle. And the client, the browser, makes a request. And then as you can see inside the app, which you'll learn more about Sinatra, if it hits a certain route, do something. This is the response. And then wait for the user again. So you will start to control that front end and that back end. Awesome. Any questions on this? I'm going to check this off. Powerful. All right. Utilize a browser to make a request and see a response.
Yes.
Powerful. Cool. Practice making a web server with React. I mean, that wasn't like that much practice, but we're not going to focus on Rack. Rack is what Sinatra and Rails are built on. And all it can do really is kind of set up a local server. And you'll see that it's so much faster and easier with the framework. And you'll get a ton of practice making this. But is there any questions so far on just the local server? Smart. Cool. Good deal. If there's no other questions, that's all I got for you this morning.